Hi everyone, so today I'm going to be verifying identities, trig identities. And so again, I'm going to be using the reciprocal functions and the Pythagorean identities and some techniques in algebra. So as a reminder, if you watched my video on simplifying trig expressions, you are going to need the reciprocal identities, sine, cosine, tangent, as 1 over cosecant, 1 over secant, 1 over cotangent. Remembering that tangent has two ways you might use it, 1 over cotangent or sine over sine. And then I always like to write cotangent as cosine over sine. Then the Pythagorean identities, sine squared theta plus cosine squared theta equals 1, 1 plus cotangent squared theta equals cosecant, and tangent squared theta plus 1 equals secant. Now, if you're in my class, you know that I always tell you these are the ones you're going to use more frequently, taking sine squared and manipulating it, as well as 1 plus cotangent and tangent squared plus 1. All right, but let's get to it. Let's verify. Verify means that we want to make the left, we want to prove the left is the right. So in this case, or we want to prove the harder side is the easier side, because you really could work with either side, but you can only work with one side. So this is where algebraic techniques come into play. So I'm looking at this, I've got a secant squared theta minus a sine squared theta, secant squared theta equals 1. Now, I know your teachers always say, oh, write it in terms of sine and cosine. This is where you actually have to use some really good problem solving skills, and you have to say, what's the smartest thing to do? And oftentimes, turning it into sine or cosine is only helpful when there's no square. When there's a square in it, I start to think of algebraic techniques such as factoring or using one of the Pythagorean identities. Here, I have to kind of notice that I have a secant squared theta in my binomial, in both terms in my binomial. So I'm going to factor that out. If I factor that out, I'm going to be left with 1 minus sine squared theta. Now remember, I'm trying to equal 1. So I have to think about that. That means everything on the left is going to end up having to cancel. All right, well, 1 minus sine squared theta using the alternate Pythagorean identity, right, is going to give me cosine squared theta. And then secant squared is 1 over cosine squared theta. So now I can see that if I cancel these, I get 1 equals 1, and I have verified my identity using factoring. Good Lord. How could that happen? Coach Fred cannot believe this. All right. Harder is when you have to factor using a method that might not look so, it might not look like what you're used to. So in this one, I'm looking at it and I see sine squared theta minus 2 sine theta plus 1. So I see a trinomial. Now, if this was of the form that, hopefully you'd see that's a perfect square trinomial, and it would factor into x minus 1 quantity squared. So I noticed that looks similar to it, and I also noticed the bottom has sine theta minus 1, which tells me I might want to be factoring the top. And so I'm going to use that structure, that pattern, to help me factor with sine. So it would be sine theta minus 1 sine theta minus 1 over sine theta minus 1. Now, remember, you're trying to verify it that it equals sine theta minus 1. Well, this factor will cancel with this factor, giving me sine theta minus 1 equals sine theta minus 1. Look at that algebra that I had to use there. I had to factor a trig identity or trig expression. So yeah, you're going to have to start thinking like that. Couple more. All right. So similar to what we did in my simplifying expressions, I see a binomial in the top with minus or plus. I see no squares, and I see a fraction. So this is where Coach Fred likes to separate. It's not the only way to do this, but I'm going to separate it by rewriting it like it was a step before I combined it. Thinking back to how I learned about to add fractions. All right, well, secant over secant is 1. And cosine over secant is cosine theta times 1 over secant theta. Getting closer. 1 over cosecant theta is cosine theta. Again, I'm trying to get to sine squared theta. Cosine times cosine is cosine squared theta. And 1 minus cosine theta is sine squared theta. So I have indeed verified my identity. All right, we're going to just do one more. This one, looking at it, again, I don't have any squares, so I can't use those Pythagorean identities. And I'm just going to rewrite this. I'm going to rewrite it as cotan theta times secant theta times 1 over cosecant theta. Remember, I'm trying to get to the number 1, so I'm really hoping all of this will cancel. So cotangent, cosine theta over sine theta. Secant theta is 1 over cosine theta. And 1 over cosecant theta is sine theta. So again, writing everything in terms of sine and cosine. And look at this beautiful problem. 1 equals 1. And I have verified my identity. All right, hopefully that was a nice introduction to verifying identities, just using the reciprocal functions and the Pythagorean identities. And I hope it was a helpful video. Have a great day.